Tes, tes. Cek. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to the 8th ITIS, or the Information Technology International Seminar, conducted by IEEE. In today's seminar, this is the 8th edition of ITIS, and today we are so happy to meet every one of you here, because today we are going to have some sessions, including keynote speeches and also some panel discussions. But first of all, I would like to deliver my greatest honor to Director of UPN Veteran Jawa Timur, Profesor Dr. Insinyur Ahmad Fauzi MMT IPU, Honorable the Dean of the Faculty of Computer Science, Universitas Pembangunan Nasional Veteran Jawa Timur, Dr. Ni Ketutsari, Dean of Faculty of Engineering, University Trunojoyo Madura, Mr. Ari Basuki, STMT. Also, I would like also to welcome the honorable distinguished speakers. First, from Raja Mangala University of Technology Tanyaburi Association, Associate Professor Dikrit Manitham. Also from Kyushu Institute of Technology, Japan, Professor Masato Turu. From the Institute of Technology, 10 November, Associate Professor Diana Purwitasari. And also to our special guest from IEEE Indonesia section, Associate Professor Endra Julianto, PhD. Also from IEEE Indonesia CSS RAS Joint Chapter, Mr. Arjon Turnip, PhD. And also to our participants, welcome, and we're wishing you a good day. Before we proceed to the next agenda, I would like to introduce myself first. My name is Aryo Bimo Otomo, and I'm going to be your master of ceremony for a few hours to come. Moving on to the next agenda, I'm going to uncover several agenda that we are going to experience today. Before we commence, we will begin by singing the national anthem of Indonesia, continued by the Mars Bela Negara. And then we're going to have several opening remarks. The first one is from the head of the committee, Dr. Agus Salim, MT. The second one, another opening remarks from the IEEE Indonesia Chapter Coordinator, Mr. Endra Julianto, PhD. The next opening speech will be delivered by Mr. Arjon Turnip, PhD, from IEEE Indonesia CSS and RAS Joint Chapter. And lastly, we would like to listen to the opening remarks delivered by the Honorable Rector of Universitas Pembangunan Nasional Veteran Jawa Timur. Dear ladies and gentlemen, after this, we kindly request you to stand up for a while for singing the national anthem of Indonesia. May all the participants stand for a while. Thank you. Thank you to all the participants. You may now be seated. Before moving on to the next agenda, I would like to also to congratulate the Faculty of Computer Science and the IEEE for their successful collaboration. Hopefully, there will be some beneficial aspects that we can gain today. Next, we're going to listen to several opening remarks. The first one is going to be delivered by the head of committee, Dr. Agus Salim MT. To Dr. Agus Salim MT, the stage is yours. Thank you. Please give a round of applause.
Assalamualaikum warahmatullahi wabarakatuh, and good morning everyone. Honorable Rector of University Pembangunan Nasional Veteran Jawa Timur, Profesor Dr. Insinyur Ahmad Fauzi MMT IPU, Dean of Faculty of Computer Science, Dr. Insinyur Niketut Sari MT, Dean of Faculty of Engineering, University of Trunojoyo Madura, Mr. Ari Basuki STMT, honorable distinguished speakers from Raja Manggala University of Technology, Tanya Buri, Associate Professor Dekrit Manitem, from Kyushu Institute of Technology, Japan, Professor Masato Suru, from Institute Technology of 10 November, Associate Professor Diana Purwitasari, and special guest from Indonesia section, IEEE Indonesia section, Mr. Endra Julianto, PhD, and from IEEE Indonesia CSS RAS Joint Chapter, Mr. Arjon Turni, PhD, conference participants, particularly those from abroad. Ladies and gentlemen, on behalf of organizing committee, it's a great pleasure to welcome you to the IEEE 8th Information Technology International Seminar 2020. Before giving the floor or the screen to the other keynote and welcome speaker, I will use this opportunity to make some general remarks and touch briefly history about ITIS conference. ITIS conference organized since 2009 by Informatics Engineering, Faculty of Industrial Engineering UPN Veteran Jawa Timur. From 2016 until 2019, ITIS was included into the International Joint Conference on Science and Technology, or we call it IGCST. And since 2020, ITIS organized under technical sponsored by IEEE Indonesia CSS RAS Joint Chapter. It means that since 2020, all accepted papers are available on the IEEE Explore Digital Library worldwide. This conference aims to keep abreast of the latest development and innovation in the advance of research area on information systems, information technology, and engineering. We proudly host this international forum to encourage students, university lecturer, and practitioner to share knowledge, thoughts, expertise, latest information, and development or related issues. This year, ITIS 2020 attracts more than 132 authors from 8 countries. The number of accepted papers is 77 papers out of 132 papers submitted, with 58.3% acceptance rate. We would like to express my sincere appreciation and gratitude to IEEE Indonesia CSS RAS Joint Chapter, IEEE Indonesia Section, IEEE headquarter USA as the main support partner for this conference. We are also grateful for the support of the publication services. All accepted and presented papers will be submitted for inclusion into IEEE Explore subject to meeting IEEE Explore scope and quality requirements. Lastly, please accept my deepest thanks to the conference participants for the contribution which are the foundation of this conference and all of committee members who have worked on putting this successful conference together. We hope that you will find conference both valuable and enjoyable. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Agus Salim, as our head of the committee for the 8th ITIS 2022. Such an inspiring remarks, and also officially opening the seminar that we are going to have today. Next, we're going to listen to another opening remarks by IEEE Indonesia Chapter Coordinator, Mr. Endra Julianto, PhD. Okay, so Mr. Endra, the stage is yours. Thank you.
Distinguished delegates, ladies and gentlemen, it is a great pleasure and honor for me to welcome all of you to this international seminar in the beautiful country Indonesia, and especially in Surabaya City, which just celebrated the 729th birthday. On my own behalf as the chapter coordinator of the IEEE Indonesia section, I welcome you to the Information Technology International Seminar ITIS 2022, hosted by the Faculty of Computer Science, Universitas Pembangunan Nasional Veteran Jawa Timur. This international seminar has been run 3 times under the technical collaboration with the IEEE Indonesia Control System Societies and Robotics and Automation Societies Joint Chapter. 2 previous consecutive seminars were organized successfully, where the seminar proceedings were indexed by the IEEE Explore and eventually in Scopus. In this year, the international seminar has the opportunity to be held in hybrid mode, offline and online, in the luxurious hotel in Surabaya City. This new mode brings enjoyment for both organizers and presenters, as after long COVID to get together for the event, the presenters and participants have good occasion to share their ideas, findings, innovation, and invention for advancing the technology. Concluding, I wish all presenters, participants, and delegates in the name of IS 2020 a successful and enlightenment international seminars. Thank you.
Thank you, Mr. Endra Julianto. Please give a round of applause for his opening remarks. Next one, we'll be having another opening remark from IEEE Indonesia, but this time from the CSS of Control System Society, and RAS, Robotics and Automation Society, Joint Chapter Chair. To Mr. Arjon Turnip, PhD, the stage is yours. Thank you.
Structured chapter, take great pride to welcoming all of the attendants and all the participants, and especially our honorable and distinguished guest speaker. We are delighted to have you with us today. On behalf of the IEEE committee, I'd like to extend our warmest welcome and good wishes to the publication of the IEEE through the ITIS 2022. It's a non-profit organization, the largest of technical professional organization dedicated to advancing technological innovation and excellent benefit of humanity. We are we like to have or to
Excuse me,
keep
Mr.
the
Arjun.
quality of accepted
Your
paper
audio is
for
down.
the submission
Excuse me,
to
Mr.
the
Arjun.
IEEE.
Your audio is down.
Yes. Is it okay now?
Still down,
Hello?
Mister?
Hello?
Yes, that's better.
Sebentar. Sorry
Still
for
down?
the
Still
technical
down.
part. Yeah, as soon as this conference is over, we sincerely request and expect all the participants to immediately examine, revise the paper, both based on the reviewer comment, the letter of acceptance, and also based on the comments, today's comments in the parallel session. For the submission to the Interpol Expo, we are from the Interpol Research team will review all of the accepted paper, and if the author do the revise properly, we would like the publication will be done normally 1 month after the submission to the Interpol. So I hope the thing that we mentioned above by means the reject and revise the paper, if we are able to follow all of the instruction, surely the paper will be published soon. And once again, thank you for the hard work of the committee so far, especially the review process after the conference, and then have the meeting for the final submission to the Interpol. Thank you and good morning.
All right. Thank you for the remarks, Mr. Arjun Turni, PhD from IEEE Indonesia. Lastly, we will also like to listen to the opening remarks delivered by the Honorable Rector of Universitas Pembangunan Nasional Veteran Jawa Timur. But he'll be presenting through the pre-recorded video as he is now unable to present around us. Okay. To Professor Dr. Insinyur Ahmad Fauzi, MMT IPU, the stage is yours. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Shalom, Om Swastiastu, Salam Bela Negara. The Honorable Associate Professor Dr. Dekrit Panatam from Raja Manggala, University of Technology, Chanyaburi, Thailand. The Honorable Professor Masato Suru from Kyushu Institute of Technology, Japan. The Honorable Dr. Diana Purwitasari, MSc, from Institut Teknologi 10 November, Surabaya, Indonesia. Vice Rector, Dean, Vice Dean, Head of Study Program of Computer Science Faculty UPN Veteran Jawa Timur. Experienced experts, friends, and colleagues. All praises to the Almighty God Allah Subhanahu wa Ta'ala, that at the end of this pandemic, we are still able to meet and share our knowledge and ideas in this very special moment. Information Technology International Seminar, ITIS 2022, dealing with information system, informatics, engineering, and technology. I would like to personally welcome the speakers, presenters, educators, researchers, and invite for joining in this special event today. Ladies and gentlemen, the development of technology has become of common things, especially the development of information technology today is indeed much more rapid than is in previous years. It cannot be denied that one of the main causes of the globalization is due the rapid development of information technology. The implementation of the internet, electronic commerce, electronic data interchange, virtual office, telemedicine, internet, and so on, has breached physical boundaries between countries. The combination of the computer technology with telecommunication has resulted in a revolution in the field of information system. Data or information that is ancient times had to take days to process before being sent to the other side of the world can now be done in seconds. Currently, it seems the people will not be able to live without a smartphone because this tool is very practical and can facilitate whatever they want. This is one of the most popular findings or innovation from advantage in information technology that has been able to greatly help people live from remote villages to big cities. That's why I appreciate the idea of holding this seminar. Hopefully that through the discussion in this seminar, there will be fun innovation that can enrich the science of information technology whose progress is getting faster. As a higher education institution, especially the information technology study program, we must not be left behind with other countries. Allow me to deliver my thanks and gratitude to today's keynote speaker who have been willing to share their knowledge and my appreciation to the organization committee. I also appreciate the young generation of the nation's future, students, lecturers, and practitioners who have joined in the event. Hopefully, all of your effort and hard work will produce a result that exceeds what we expect and will certainly provide extraordinary benefit for others. The result of your research, innovation, and work are being awaited by the community, researchers, and society. I wish you a lively and fruitful discussion. May Allah subhanahu wa ta'ala, the Almighty God, provide protection and direction at all times, so that our action result in positive outcome. By saying Bismillahirrahmanirrahim, I herewith officially open today's forum. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you to Rector of UPN Veteran Jawa Timur for his impressive remarks. And to reiterate what the Mr. Rector has just said to us. First of all, hopefully the seminar can enrich our knowledge, especially in the fields of information technology. And secondly, to segue us into the next session, let's don't forget to thank the Almighty God for the opportunity that we have today. That's why the next session will be the opening prayer that will be delivered by one of the lecturers at the Faculty of Computer Science. To Mr. Aris Pratama, the stage is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Let me lead the prayer in an Islamic. Ladies and gentlemen, please be willing to adjust according to your respective belief. Bismillahirrahmanirrahim. O Allah, open for us the door of virtue, the door of blessing, the door of grace, the door of strength, the door of faith, the door of health and salvation, because only you are the most gracious and most merciful. O Allah, give fluency to this ITIS 2022 conference until it's finished. Amin. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you, Mr. Aris, for leading the opening prayer. Now that we have commenced officially our seminar, let's begin with the next session. That is the virtual photo session with our opening speakers. And to our participants, also please open up your camera because we are about to take a virtual photograph. Okay, the committee, is it ready? Okay, thank you. Okay. Continue with the next slide or the next agenda. Is it finished? Finished? Okay, thank you. Thank you for all the participants and our opening speakers. The next one, for the next one, I will give the stage to our honorable moderator, Mr. Wahyudi Agustiono, PhD, because after this, we're going to commence our main session, that is the keynote speech sessions. We're going to have two distinguished keynote speakers. The first one is Associate Professor Dr. Dekrit Manitam. And the second one, we're going to have Professor Masato Suru to discuss his theme with us. And also, we have another keynote speaker, Mrs. Diana Purwitasari. So after this, for the next few hours, we're going to have the keynote speech session. For all participants, we are wishing you a nice conference. We're expecting you to ask good questions, and hopefully, this discussion can enrich our knowledge. Okay, to Mr. Moderator, Dr. Wahyudi Agustiono, the stage is yours. Okay, there's been a change of plan. The moderator will be the stage will be given to Dr. Irwan as our moderator today. So Dr. Irwan, the stage is yours. Thank you. Please give a round of applause.
Thank you, Mr. MC. Must be more, ya. Ini, ya. Ya. Okay, let's just begin. Assalamualaikum warahmatullahi wabarakatuh. The honorable keynote speakers of ITIS 2022, the honorable rector of Universitas Pembangunan Nasional Veteran Jawa Timur, Professor Fauzi, the honorable vice rectors of Universitas Pembangunan Nasional Veteran Jawa Timur, and also the deans of faculties of Universitas Pembangunan Nasional Veteran Jawa Timur, the ITIS 2022 committee, all ITIS presenters and participants. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, or perhaps good afternoon to some of you who live in the eastern area of the Surabaya, including one of the speakers, Prof. Masato Suru, who is joining us from Japan. So I believe now is 11 something in Japan. So it's good afternoon. Um, Welcome to the 8th Information Technology International Seminar held by the Faculty of Computer Science of Universitas Pembangunan Nasional Veteran Jawa Timur, supported by the IEEE Indonesia Control System Society, the CSS, and Robotics and Automation Society joint chapter. This year's themes is Information Technology Transformation Amidst Digital Disruptive. Ladies and gentlemen, we are now entering our main event, the keynote speaker session. But let me start first by introducing myself real quick. My name is Muhammad Irwan Afandi, or just Afandi in short. Yeah. I will be the moderator of the session. You know that after a tsunami of COVID-19 in the past 2 years, in the last couple of months, it's been very encouraging, it's been very promising and relieving to all of us, which opened up opportunity for us to come to this room, joining together in this big event, ITIS 2022. The event of ITIS 2022 shows the strong will, the strong commitment of the Faculty of Computer Science of the UPN Jatim to help contribute to the development of science and technology in the area of information technology and information system, which is in line with our national motto, pulih lebih cepat, bangkit lebih kuat, or recover faster, rise stronger. Before we start this session, please allow me to greet our honorable speaker first. For this session, there will be 3 keynote speakers. The first one is Associate Professor Dr. Dekrit Manitam from Raja Manggala University of Technology, Tanyaburi. He is joining us online. Are you already with us now, Dr. Dekrit?
Hello. Okay, I already.
Oh, great. How are you, doctor?
Yes. Okay, I'm okay.
Okay, good. It's so great to have you in this seminar. Okay, and the second speakers will be Professor Masato Suru, or Masato Sensei. Are you with us already, Prof. Masato?
I'm sorry, Prof. Masato Suru will join with us on about 10:20, 5 minutes before his sessions.
Okay, sure. Okay, no problem. Okay, so and the last but not the least of our speakers, Associate Professor Diana Purwitasari, would you join us here? Or you will wait for your session? Or you can join us. Okay, she is already in this room, so it's great to have her here. Thank you for allowing us to meet you in person, finally, and giving a chance to listen to your speech directly. All right, I think we have all our speakers ready for this session. The committee has arranged the session to be a continuous presentation by all speakers, one speaker after another. And then at the end of the session, there will be a question and answer section. Regardless of your location, please mention your nickname, affiliation, country of origin, your brief question when you raise a question. Hopefully, we all can gain something, learn a lot from this presentation of discussion with all the speakers. So I start with our first speaker, Professor Dekrit. Before Professor Dekrit begin his presentation, let me read real quick his short profile. He is the head of Mechatronics and Robotics Engineering Department of Raja Manggala University of Technology, Tanyaburi. His main research interests and expertise are in the area of biomedical applications, robotics and automation applications, and mechatronics application. In the last 33 years, he has been working as an academia for 25 years, and also had worked in the industry for 21 years. So it's a unique and rich combination as well. So he has a patent registered in Thailand. He has also 11 books about microcontroller and robot, and also 47 plus publication based on this Google Scholar. So without further ado, please welcome Professor Dekrit to deliver his speech. I would like to remind Professor Dekrit that given the time limitation, please deliver your presentation no longer than 15 minutes. Thank you. The time is yours, Professor.
Okay, thank you very much, Professor. I will open a PPT before. Okay. Okay, good morning, Professor and ladies and gentlemen. My name is Dr. Delit Tham, Head Mechatronic Engineering Department in Ratchamangala University of Technology, Tanjavuri, Thailand. I'm so happy to join this IEEE conference. So now my department opened a master and doctoral international program. Then I need to show for this my research divided my research in mechatronic engineering and divided industrial robotics, agricultural robotics, and biomedical robotics. I will present one by one. Okay. The industrial robotic, the definition of robotic divided for function, mechanical, electrical, electronic, and computer-based to control production process. So really famous for this industrial robotic to use lots of factory. That means for first type, Cartesian and rectangular. These are divided T as linear, x-axis, y-axis, and z-axis for left side to right side. Example for this overhead cranes. Then for this robot types can industrial application, casting, production placement, pick storage, packing automation, general machine operation. And second one, cylindrical robots. These are divided two linear x-axis and z-axis and one rotation. This can application for assembly operation, handling machine, spot building, handling, die casting. And number three, spherical or polar robots. These are like combined with rectangular or cylindrical, divided two rotation and one linear. Linear means for this x-axis. That's industrial application, assembly operation, pick and place, painting and building. And these are number four, lever loose. A lot of for this axis to use many famous industry. These are I show for this T rotation. This means rotation 1, rotation 2, and rotation T. This industrial application must be used for assembly operation, pick and place, okay, spot welding, manufacturing, and lots of for this in use in factory industry. For this you can approach to 6-axis or 7-axis. There's a lot of rotation. Number 5, Scala robots. Scala robots are famous together. These have the two rotation and one prismatic. Prismatic follow for the C-axis. Can application, assembly operation, pick and place operation, die cast, machine vision, material casting. And last one, industrial robotic, like parallel robots, lots of angle. That means to show 4 degrees of freedom, very high speed. For this robots can move a lot of specimen if we have the capture via camera. Then that's that example for this belt conveyor below this robots. Okay, this robot can movement pick and place like OK and NG. NG means not good. After that, camera can capture before the slow can move. This for you for high speed, high accuracy, and position together. This very nice for this kinematics of robotic calculation. And the table, this conclusion for this six robots, okay, divided Cartesian or rectangular opposed to parallel robots. Cartesian rectangular advantage, rigid structure, T linear axis, this line OH chains, and this advantage to use working space is similar than this robot size. This to use high space opposed to parallel robots. This advantage for the high quality rotary joint, but for disadvantage more limits for workspace because it's very not so long for this trajectory. Okay, sorry. Oh, sorry. Presentation didn't move. Okay, I will check again. Also, my slides cannot move. Okay, move already.
It's not moving yet, Professor.
Okay. Sorry.
I think it should be moving now.
Okay, moving now.
Probably.
That's hello, moving now. No.
We can see your presentation moving.
Hello, Professor. Sorry for this presentation. Okay.
Yes.
So I discussed about this number 4, number 5, number 6 parallel robot, and lastly for this several advantage and disadvantage for the 6 robot divided Cartesian opposed to parallel robot. That Cartesian have the advantage and disadvantage opposed to parallel robot. High advantage for high quality rotary joints and disadvantage for this workspace very limited. Okay, and these are industrial robotics divided many control. I can divide this T function at first computer control PLC and microcontroller. That's our first computer must be controlled via RS-232, RS-285, or IEC standard protocol. And if you control a robot via PLC, that PLC lots of more than 30 types in the world, divided Europe and Asia zone. Europe means Siemens, Blackhawk, Allen and Asia Zone mean Mitsubishi, Omron, and Toshiba. So lots of the PLC you can select this. And lastly, a microcontroller studying for Motorola CX0, okay, and MZ51 for Intel's big for microchip, and lastly, Arduino from AVR. So these are lots of controller you can choose for this how to control robots. I will show for this industrial robotic arc welding for my doctoral student, Mr. Louis. He can do for this arc welding for this industrial robot. This industrial robot can make it by itself. That's been can design for this 6-axis. Lots of design can design via SolidWorks like a lot of parts starting axis 1, axis 2, axis 3, axis 4, axis 4, 5, approach to axis 6. So now lots of material to use with cast iron material. Then can have the payload 6 kilo. And 5-axis and 6-axis must be used for this harmonic gears. This harmonic gears to high precision and high torque together. That's been like a hub to control lots of the position or lots of axis must be used for this harmonic gear together. Then until he can do for this industrial robotic 6-axis. After that, studying for the 6-axis, can jump with the camera together, can detect for this a lot of specimen before this welding. After that, welding lots of inside for this algorithm together. That's for algorithm, transformative and control servo, a lot of for this electronic and equipment for this industrial robotics. So for this figure to show for this guy for this robotics inside for this control system. Devices T servo die. One servo die can control 2 AC servo motor. This single phase. Okay, this 6 servo and capture via the camera for send input to robots. After that, CPU can generate, and then robot can movement follow for this capture via camera. Okay, and this industrial robotics must be used for this for function for link twist, link angle, joint distance, and joint angle together. This follow for this figure light side. Then can measure for along this x-axis and z-axis together. Follow for this David Handenberg. And last one for this transformative system for this after calculation for this DH parameter. And then for this DH parameter, after a student get for this robot already, they will make a lot of parameter divided for function link twist, link angles, joint distance, and joint angle together. After that, the law figure to compare with Yaskawa robots. Then need to show for this must be as nearly as or payloads 6 kilogram together. And then for this when to make industrial robotics must be simulating with MATLAB together. That's MATLAB must be generated by Petercock software. After that, to generate for links simulating, then must be compared with experiment and finally solve together. This graph that's same or not. And then must be known for this robots work spend a lot of area for this robot to movement left side, right side, and many angles for this robots must be have this calculation because this robot actually to move 360 degree. So now we move 370 degree. Must be more enough for this robots because there are lots of angles. Then thus experiments and simulating arc welding robots can show for this after make then can fast angle 30 degree, 45 degrees, 60 degree until overhead welding together for this robot. I need to show for this video for this industrial arc welding. Then after finish they can use for this robots until this robot can to do for this loss of hardware. Okay, this welding this to show for this fat angle. Okay. Okay, this control via 6 servo robots. Okay. And the second one, this master student to use parallel robots for this TDG of them divided T stepper and T microcontroller together. That can divide this software control and hardware. The software to use with lab viewers, vision, lab view and vision builder, and that's C part together. And control to use microcontroller and hardware to use a stepper. After that, this hardware can move or follow for this objective and scope together. So now these parallel robots, lots of angles. Okay, this must be follow for David Handenberg. Divide this forward kinematic and inward kinematic together. This a lot of angle for this to use in factory. And then to show for this source code inside for this hardware divided C pass, they can control as a stepper can move it follow for this position and speed together. And then it's these experiments and simulation to show a graph for this T as degree of freedom. So now I need to show for this simulating for MATLAB software. Okay, for this if T degree of freedom are moved, that means for graph can move together. This final result for this parallel robots. And this intelligent robotics. Intelligent robotics divided low level and high levels. Low level divided can control steering, control brake, and control speed. And high level can control GPS, camera, compass, and sensor. After that, you can combine with T control devices POC microcontroller. After that, generate send output to hub like a computer can control a lot of for this industrial like intelligent robotics. So after this, we have this intelligent vehicle and bicycle. Then I send for this student to a competition with bicycle and vehicle. No have the person that means I like unmanned, and you can look for this vehicle can move a lot of obstacle can show it like a green color. You can move point 1 to point 2. That's up to you to decide. This control via sensor and GPS together. And the low ones, these are for bicycle. But bicycle, I discussed about the T function for control devices, computer, PLC, and microcontroller. But up to you, you can decide for this loss of control until you set and this your bicycle can set a balancing robot. Okay, cannot fall down. And second one for this agricultural robotics. Agricultural robotics, this doctoral student to make a tractor. The first one or Taiwan divided hardware, software, and software control and hardware. The same for this robot together. The software, so lots of software can control via C++ and C#. And control that's how to control for this steering and high level. Okay, this steering mean low level before. I jump this tractor jump with master and doctoral together to research for this topic. This master can do for this low level how to control steering, and doctoral can control for high level. That's mean for GPS and sensor. Okay, this I have this video together for this tractor. After that, tractor can control by itself. Then for this control a steering, like a steering control, that's tractor can move the position to position one by itself, and this follow for this GPS together. Okay. After finish, they can jump to a control with high level. Okay. And second one, agricultural robotics pass through for plasma automation into a view as die hand tractor using embedded control system. He will get for this loss of data from Bali's. Okay, so for this problem statement from a live field smart farm. Then for last time we can divide this traditional technology and modern technology. He select to modern technology how to control like intelligent vehicle. So now this tractor unmanned together. So now this devices hardware and control with ESP32 and sensor for GPS, MPU 6050 and compass and camera together. After that, he can lots of data from. Okay, this at first control via the remote before, so this tractor can move by itself. And next one, he can keep a lot of data in the yard. Okay. Okay. This one. Okay. Robots can move by itself. Okay, this follow for this camera and part panning together. He can do a lot of paper. This very nice for this tractor. This because there's this the topic for agricultural robotic. I have a lot of tractor, and then for last one he can publish a paper via MPIs. Okay, this paper for plasma can publish with MPI journals. So I will slide down. He can detect and to keep a lot of data via camera together. These are like advanced and how to get for this data via part panning for this tractor. Okay, this part panning together. This finish for plasma. And last one, bio robotics. Okay, this bio robotics. This really is a problem for in Thailand. You know, this have this problem for the south of Thailand have a lot of wildlife. Then I need to help this soldier. There's a lot of problem and injury. Then as for this Pak Ilang can do it for this like as hemiplegia or one legs. He can get for this problem statement. That means for if you know for this local math very expensive when you practice or in a lot of hospital. That's until we can do for this exoskeleton. Okay. That's exoskeleton one legs. He can compare with David Handelberg's design together. After that, we have the two joint, hip and knee together. Then we can calculate and to design for this experiments for this bio robotic. So for this control devices, AC, DC servo, two DC servo, that means two links, and microcontroller and power together. After that, jump with encoder to detect position and speed. For this bio robotics. Then I will show for this keep some data when experiment. So he can design for this robotic. After that, he will get for this publish a paper for IJEC. Okay, IJEC. These are control robot assist gate using a hybrid positional or integral derivative and ILC. This control. So I will slide down here. Can jump with control theory and this with kinematic and a lot of us kinematic devices are for the two axis. Okay. Then mechanical design. This with compare with knee and joint and motor together. After that, for this PD control and hybrid PD and ILC for this schematic with hybrid controller. After that, he will get for this the graph, the final result. Okay. And as biorobotics type 2, I will do for this exoskeleton because that's for this for paraplegia and quadriplegia. That's they cannot move because that's I can do for this exoskeleton because there's exoskeleton if we as being as for boss very expensive. Okay, I try to do for this exoskeleton for the shoulder. Then this exoskeleton have lots of axis divided hip, knee, and ankle. So this light side to show parameter for David Handelberg's for this left hips and right hips, left knee and right knees, and last one for left ankle and right ankle. That means there's a lot of axis you can design and control with via David Handelberg kinematics. Okay, so I will show for this video for I will show this after finish I will show for my King Silinton. Okay, for this exoskeleton robot. So to show this my government together after King Silinton looks okay. This very significant for this patient. If patient has a lot of patient in the world the problem like paraplegia, they can move. Okay, so very sympathy for them. Okay, you can add more for this until life cover and, until this hardware can do it. Okay. And last one, okay, I will show for this my research for this hemiplegia. This hemiplegia like as one leg. Okay, this example for some people this can move. They have this only one leg. How to bring them to move another way. Then for this I will move for right side. Okay, you can move left side or right side. Then as that example for right side problem. They have the paralyzed how to bring them to outside and left side is good. Okay, and this last one for this quadriplegia. This quadriplegia this problem for this soldier in Thailand. They cannot move. That's now they can move starting for shoulder to leg. Shoulder to leg cannot move. They can move for head only. So you can look from this how to bring them to on the base. That's they can move after they accident for the south of Thailand. Okay, they can move head only. That means for this positive PGA until I do for this gyro sensor. So gyro sensor still on the head. After that, they can move the left, the right, follow for this function for this wheelchair. They really happy after they use for this my hardware. I think what is really significant for this industrial robotics by industrial robotic, agricultural robotic, and biomedical robotic. Okay. Thank you very much, Professor. Okay.
Thank you so much, Professor Dekrit, for the presentation. It's a very nice presentation from him. We can see, we all can see the application of mechatronics for many different various ideas, including the health, yeah, the last one, for the to support patients in hospital. I saw in the other slides that you have provided to us, and that you have also created wheelchair with head and voice control, and also wheelchair with toilet. Yeah, I can even see that too, and also a device to lift and move patient, and also the exoskeleton robot that you just show us the video. It was a very nice presentation. Hopefully everyone in this room and also those who are joining online can learn something from it and inspired by it, and perhaps discuss more with Professor Dekrit Manitam later on in the QA session. So thank you, Doctor. Now we are going to move to the next speaker, which is Prof. Masaru. Are you already with us, Professor?
Hello? Can you
Hello?
hear me?
Yes, yes, we can hear
Okay.
you, but just a little bit, the volume is not too. Can you try once more time?
Just wait.
Hello?
Hello?
Yes, okay, we can hear you.
It's okay?
Yeah, it is okay. Okay.
Okay.
Okay, let me read your profile just for a minute so that the audience know who Prof. Masaru is. Prof. Masaru is a professor at Faculty of Computer Science and System Engineering Department of Computer Science and Networks, Kyushu Institute of Technology. His main research interests and expertise are in the area of computer network and information network. He has been very productive in publishing scientific articles. If I refer to the Google Scholar, there are 387 papers in all. He won several grants for network-related research. He has been invited to give speech in many workshops and seminars. He is also a member of ACM, Information Processing Society of Japan, and other societies. Today, he is going to deliver a speech entitled "The Fun of Routing and Scheduling Problems for Fast Delivery and Collection of Distributed Information." So without further ado, please welcome Professor Masato to deliver this speech. I would like to remind you, Professor, that due to time limitation, your presentation time will be 45 minutes. Thank you. The time is yours.
So, just wait. Just wait. スライドショー最初から。Can you see my slide?
Yes, we can see your slide.
Okay, thank you. So, thank you very much for giving me.
I'm sorry. Maybe Suru-sensei could share full screen because we just see the window of PowerPoint.
So, do you see the full screen?
So,
it's not in the slideshow mode actually right now.
Sure. It's okay? Oh, I changed the original one. How about this?
Hello, Mr.
Hello.
Hello, Mr. Masato.
Hello. It's okay.
Yeah. You can use the presence button, share screen, and choose the entire screen.
What?
Please end the slideshow first and back to StreamYard.
Back to stream. Just wait. こうやって。Sorry, this is first time to use StreamYard. Share.
You can look on the private chat tab. Private chat. I have already sent the quick tutorial.
And presentation. 違う。モニター。How about this?
Can I help you with the remote desktop from here?
Remote desktop?
Yes. I can get you with the remote desktop if you need assistance from us.
I don't.
Have any...
Just wait.
Okay, I will get you step by step.
Okay.
Please back to the browser.
Browser?
Yes. Okay, you can see us, right? In the StreamYard. All right.
Yes,
There is StreamYard. Okay.
Yes.
Present button below the screen.
Presentation.
Yes. Okay.
Okay.
Choose the share screen button. Share screen.
Slide screen?
Yes, share screen. Okay. Present button. Press the present button and choose the share screen.
Just wait.
Okay.
Oh, sorry.
Okay.
Share screen, yes.
Yeah, choose the entire screen, and you good to go. Yes, entire screen. All right. Choose the screen first and share, and you can go back to the PowerPoint.
Oh. Okay, I understand. Just wait.
Okay, you can go back to your PowerPoint presentation and open from there.
It's okay?
Okay, you're good to go.
Oh, thank you. Thank you very much. So, so thank you for giving me an opportunity to present my talk. And I appreciate very much you are promoting this great conference, especially for General Chair, Professor Agselin, and all other organization members and staffs. So before starting my talk, I would like to introduce my university, QTech. So this is Japan, this is Kyushu Island, and this is Fukuoka Prefecture. And in Fukuoka Prefecture, we have 3 campuses. And I work in Iizuka campus here. And this campus is mainly for computer science and system engineering. We have about 5,000 students, including 300 international students from 39 countries. And we have 500 faculty members. And we are engineering university, but very diverse topics we have. And for example, satellite technology and green technology, power electronics, and AI chip. And also, we have many collaboration with international foreign universities. This is a double degree program between QTech and other university in the world. Okay, so now we would like to start my talk. So there are many recent ICT keywords like 5G or beyond 5G, IoT, edge cloud computing. And they all are distributed but managed. And the goal is smart cities, disaster resilience, or SDGs. And this picture shows the fixed and mobile internet traffic in Japan. This graph clearly shows the data explosion still continues. Orange line shows the downstream traffic by broadband fixed line subscriber. At May, this May, it is about 26 terabit per second. And orange line shows the download traffic by mobile phone subscribers. It is about 5 terabit per second. And this here, this rapid increase may come from COVID-19 situation. So we are in data explosion era, and as you know, there are 3 technology layers to against this data explosion. One is the application layer to reduce resource consumption. On the other hand, the physical communication layer is to increase available resources, but the physical resources is finite. So our focus is this middle layer, optimizing resource sharing. We need to share the limited resources, network resources, among multiple diverse users and services. So today's talk is on this topic, and we consider routing, scheduling, coding, and caching. As you know, there are some approaches to fast information networking. One is reduction of network resource consumption, and the other is utilization, efficient utilization of the spare or unused network resources. So green colored technologies, multicast, coding, in-network casting, multipath scheduling, are today's. We use these techniques in today's talk. Okay. So also, as you know, there are new, not very new, but in these 2 decades, 1 or 2 decades, we have new technologies, SDN and SCF. Software-defined network separate data plane and control plane. And more importantly, they introduce the programmability of networking. So it can realize the flexible and automatic operation or control of network. OpenFlow, I mentioned later, is a somewhat old technology to program the control plane only. But recently, P4 programming protocol independent packet processors is developed and become popular to program the data plane itself. On the other hand, store carry forward networking integrate the information carried by vehicles and conventional communication networks. It is originally for rural areas or disaster situation in the context of delayed tolerant networking, DTN. So this picture is from this paper, The Road to SDN 2013. This provides a very good but somewhat old history of SDN. So it is, if you have interest, please refer this paper. And so carry forward in VTN context, this paper shows a good perspective of delayed tolerant networking. X-axis indicates the link stability, so very unstable to very stable, and y-axis shows link distance or propagation delay, very short distance and very long distance. For example, this area is an ad hoc network, and this area shows, for example, deep space interplanetary networking. So in this perspective, maybe in this part, store carry forward paradigm networking is very important role in DTN. Okay, so we move to our contents, and the first one is powerful routing and scheduling program in SDN environment. So, as you know, there are much demand for cloud or distributed or edge computing or content delivery networking. So, fast and efficient file delivery among data centers is very important. It should be done on a managed network. So, we propose a multipath multicast transfer, MPMC. So what is MPMC? There are single sender and two recipient, A and B. So senders want to send this file to A and B as fast as possible. So we assume the fully managed network with full duplex links. This means that this link is full duplex. And what is multipath transfer? In multipath transfer, a file is divided into multiple blocks, like 2 blocks here. And blocks are transmitted on multiple paths. So green block go through this path, and yellow block goes through this path. But actually, in real network, the unit of transmission is data packet. So block means a sequence of data packets. But for simplicity, we call block as some single object. And multicast. In multicast, a block can be replicated in network. So this green block comes here and replicated to and sent to not only A but also B at the same time. So we can use the multipath transfer and multicast transfer and multipath transfer integratedly. Okay, so some terminology we explained. So sender transmit block to each recipient using his own max flow value. Max flow value means full. If sender to receiver network can use full capacity like this. So S to RC's max flow value is 3 in this case, and S to recipient A max flow value is 2 like this. Okay, we assume this part is infinite capacity, so bottleneck is always here or here or here. So max flow value, by utilizing the max flow value, we need to divide file into blocks. The number of blocks should be least common multiple of all recipients' max flow values. In this case, 6. So the goal of MPMC is each recipient retrieves the file in its lower bound RTC, retrieval comprehension time. So what is lower bound? Lower bound means a file size divided by its max flow value. In addition, we use sender-side coding. So what is the benefit of sender-side coding? If, for example, if we use Reed-Solomon coding, and original number of n is number of original blocks. In this case, A have block 1 and 2, B have block 2 and 3, and C has block 3 and 1. In this case, we generate a coded block from 3 original blocks. So this is number 4 block. And send only block 4 using a multicast. So A has 1, 2, 4, B has 2, 3, 4, C has 3, 1, 4. But this is, we use a Reed-Solomon coding. This 1, 2, 3, original block 1, 2, 3 can be decoded, and each recipient already retrieve the original file. This is the benefit of the sender coding. So by using MPMC and sender coding, we can optimal one-to-many file transfer. This is a simple example. So file is divided to 6, and the first phase, and one additional coded block. And S send block 1, 2 like this, and block 3, 4 like this, and block 5, 6 like this. So in this case, in this time, receiver C already have 6 blocks, so he finished. But A, D, B has 4 blocks, because their max flow value is 2. And the set is received blocks are different here and here. Then go to second phase. S send 7, coded block 7 here, and 3, original block 3 here, and original block 5 here on green line. This 7, 5, 3. As you can see, each receiver A, D, B have 6 different blocks. So they can retrieve, they can decode the original file at this point. So second phase, all receiver finish. So that is very simple example, but it can be applied any complex network. This is some complicated network example. This is sender position, and all other 46 nodes are receivers. And we can find the optimal multicast tree, 7 multicast tree, to for all each recipient to receive files in its lower bound time. In this case, original block is 420. Okay. So this scheme can be implemented in OpenFlow framework. So this is OpenFlow switch, and this is OpenFlow controller. So some preparation, then OpenFlow controller can generate the scheduling and set up the schedule to each switch, install flow entries in each switch. Then sender starts the transmission. Sender starts the transmission. And in some case, there are some packet loss. So there we need to implement the transmission mechanism to recover the lost packets, not block. Lost happens packet by packet. Okay. And we already verify this prototype implementation on a global testbed. And this is our university, and this is Japan Research Network Backbone, JGN. And this is OpenFlow testbed on JGN. This point is not only Japan, this is at Seattle. So we use this global international testbed. We validate our OpenFlow implementation. And RISE and JGN is operated by NICT. Okay. So this is a simple experimental result. This is theoretical reception time for each recipient. This is in network in labo recipient, and this is in the RISE. Maybe this one is on at the Seattle. And if there is no packet loss happen monitored, this case, the real experimental reception time is almost same, close to theoretical value. But if packet loss happens, we need a retransmission of lost packet, so the time is slightly increased. Okay, so what's next? So this is just for a single one-to-many file transfer. So in reality, there are many different independent one-to-many file transfer. So we need to manage the multiple one-to-many transfers at the same time. To realize the first one, we call it many-to-many file transfer. And to realize the first many-to-many file transfer, we need to use in-network block replacing by using in-network casting. In-network block replacing means replace a flowing block at a switch to another block which was cached at the switch before. Okay. And this can be implemented by recent P4 technology. So this is some simple example, but due to time limitation, we don't go detail. But in this case, A want to deliver the file, this file, block 1 to 6 to BCD, and host D also want to deliver this file, block 1 to 6 to ABC. So this one-to-many file transfer runs at the same time. So this is first 3-second scheduling example. In this case, we prioritize A to BCD transfer than D to ABC transfer at some extent. And block D6 is cached here, switch 1, and used later. So as a fourth second, at this point, the transmission, file transfer from A is already done. So only D to B and C are remaining. And in this case, this block D2 is multicasted from here, go to this direction, but this direction, block D2 is replaced to D6. So in this way, C can receive D2 from along this path, and D6 along this path, and D4 along this path. So 3 different blocks can be retrieved by C at this point. Although D can send only 2 different blocks. By using this, the reception time from D to C is improved. Okay, so we go to the next final topic. This is maybe completely different scenario. It's a vehicle routing and scheduling in software store carrier and forward scenario. We consider the information collection in disaster area. So large-scale disasters happen very frequently. So in such a situation, it is important to collect the disaster information promptly and without communication infrastructure, because sometimes the communication infrastructure is broken and damaged. So we want to consider the vehicle routing and scheduling problem to collect the information as fast as possible. Okay. So in this scenario, vehicles should collect disaster information and start from the emergency response headquarters HQ with cameras, mics, radar, laser, etc., such as sensor devices, and monitor all streets in the area and bring the monitored information to headquarters. And important thing is they can return to headquarters multiple times to drop a partial information monitored before, like this. Return first time and drop collected information, and then go through the remaining street and finally go back to the headquarters. Okay. So what is a good route? So we need to define the performance metrics. So this graph shows this is time, x-axis is time, and y-axis is UT. UT is a fraction of the information collected to headquarters by time t. For example, in the previous one, if when the car vehicle return to headquarters this time and bring the information, the fraction information 0.45, and then go through other streets, and finally go back the headquarters to bring the remaining information. So in this case, UT is like this. And we consider the area of this. First, so this is the time the vehicle finally come back to headquarters. This is, of course, important. But more important thing is IDP, information delay time product. This means the area of this. So this means this represents the average delay time in incremental collection of information, and can be defined this formula. Okay. So we can do a simple analysis on IDP. This part is for single vehicle. So unit time is taken by a vehicle passing a link. This assumption, simple model. The unit information is monitored by vehicle passing a link. And R is the number of returns to headquarters, and N is the number of links. So we set some variables. J's return time of vehicle. Vehicle return to R times to headquarters, so the entire route can be composed R different rounds. Okay, so this is return time of J's round, and this is fraction of information collected by the J's round, Wj, and this is some overhead, means the number of redundant passes of links on J's round. By using this notation, IDP can be expressed by this formula. This is almost the same as the definition, integral definition. And we can show this is equal to this one. Okay. And there are some very simple example. Okay. Headquarters is here, and the number of street is 14. This is Eulerian graph. So explanation is very simple. And in this Eulerian graph, and if return number of 1, this means headquarters goes through this area and finally go back headquarters only once. In this case, any Eulerian circuit is the best route. And IDP is 14 and LID is 14, like this. He comes back time 14 and brings all information at the same time. So the IDP is 14 and LID is 14. So we consider the R equal 2. What is the best route with R equal 2? 2 returns. By using some mathematical analysis, this value is best lower bound. And also this lower bound can be realized, this path, this red route. Okay. So in this case, UT graph is like this. And also we can show in R equals 3 case. So 3 times return to headquarters. By using this, the theoretical lower bound is this value, but this is infeasible because this value is just an analysis in real number, not consider the real topology, real network. So this is lower bound, but actual minimum IDP is this value. Okay. And this value is realized by this green route. these green rounds. Car returns to headquarters 3 times. And UT is like this. First time return, second time return, and third time return. Okay, so from this analysis, we can have some implications. In general, there are trade-off between number R of return rounds means the return number of returns, and redundancy. If returns increase, they need to pass same link multiple times, so redundancy increase. But rounds should be well balanced, and early stage round should bring more information more efficiently. This is a condition of a preferable condition for good route, small IDP routes. Okay, so we consider 2 different collection schemes. One is the independent collection, and another is the collaborative collection. Okay, so this is independent collection by 2 cars. Okay, so in this case, the goal is design a pair of route to minimize IDP. And right-hand side is collaborative collection. So in this case, in collaborative collection, we set up a pickup point with storage and Wi-Fi. And this car stores the information to already monitored information to this pickup point and go another way. And then this car comes here and pick up the stored information and bring it to headquarters first. Okay, so we can consider independent collaboration and collaborative collection with pickup point. Of course, in this case, we assume the reliable street map is available before and the streets are normal condition. So all streets can be passed normally. This is some example of systematic search of good routes. Node number is 20 and link is 31. Number of link is 31 and number of beacon is 2. And this is headquarters. And we compare, we find the best route in independent scheme and the best route in collaborative scheme and compare. And to perform a systematic search, we leverage a Chinese Postman program. So this is the result. We change the number of returns 2, 3, 4, and compare the collaborative and independent. This is 5 case. This is R equal 2 and independent. R equals 3 independent, R equals 3 collaborative, like this. And as you can see, the LID, so the final return time is smallest in R equal 2. Small number of returns means less overhead. So LID is very small, but IDP is not small. The best IDP route is return number is 3 and collaborative, like here. Okay. So from this figure, we can see, what I already said, case 1 is best shortest LID, and case 3 is best shortest IDP. And compared between collaborative collection and independent collection, we can see collaborative collection is always good. For example, case 3 and case 2, case 3 and case 2, and case 5 and case 4. Okay, so collaborative collection can shorten the IDP. So what's next? So it's very simple and analytic. So we should be more practical and applicable. One is in searching good routes, it should be more scalable. So there are some means, area segmentation, or more efficient search algorithms, more intelligent, efficient search algorithms. Another one is we should consider the disaster situation. So road conditions risk. It means more robustness. We need more robustness to apply a real situation. So we need to consider the probabilistic or unknown disaster damage on some link. And finally, should be more flexible in deployment. So initial location of patrolling vehicle may not be. Sometimes it is not start from headquarters. So initial location can be changed in more different location. And also location of pickup point can be flexible. And energy consideration is also needed for cost and flexible deployment. Okay, so this is the end of my second talk. In summary, today I explain the distributed but managed information networking example, especially for flexible routing and scheduling by SDN and CSF. First one is delivering large files among data centers by using multipath, multicast, sender coding, and in-network casting. The second one is collecting disaster information to headquarters by vehicle. We design a collaborative collection using pickup point, and we show its benefit. Okay, it's the all of my talk. Thank you for your attention.
Thank you, Professor Sado. It's been a very interesting presentation from Professor Masato. We have learned a lot from what he present. As we know, in Indonesia, similar to Japan, we hear natural disasters almost in daily basis. So
yes.
The fact that you have done many research in this area is very relieving, because we have so many disasters like earthquake, floods, typhoon, hurricane, tornado, something like that. And if the magnitude of the disaster is huge, the information infrastructures is frequently knocked down and make it difficult for everyone, including the disaster officers, to communicate with each other or to respond promptly to the needs of the affected area. So the research by Professor Masato shows us the opportunity to solve this problem. So hopefully at the end of this session, there will be many participants who will ask questions to you, Professor.
Yeah.
Thank you again. Let's give an applause for Dr. Professor Masaru. Okay. So now we are moving to the last speaker of our ITIS keynote session. So I would like to invite Associate Professor Diana to come to the stage. The committee, can you prepare the Prof. Budiana presentation? The slide. Okay. Okay. Before Associate Professor Diana start her presentation, I would like to read just a short profile of her. Professor Diana right now is currently the Vice Dean of the Faculty of Intelligent Electrical and Informatics Technology, Institute Technology 10 November Surabaya. She is an expert in web mining, information retrieval, social network analysis, and also computational intelligence. She is also holding a key position in several professional organizations, societies, and teams, such as the Vice of University Center of Excellence on Artificial Intelligence for Healthcare and Society, Chief of East Java Province Chapter for Community of IAIS, Indonesian Artificial Intelligence Society. She is also the member of Indonesia AI Research Consortium by the Ministry of Research and Technology to design task force of AI towards Indonesia Vision 2045. And also senior professional engineer in the Institution of Engineers Indonesia. So without further ado, please welcome Professor Diana to deliver her speech. I would like to remind you, Professor Diana, that due to time limitation, your presentation will be 45 minutes. Time is yours, Professor.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good noon. I think there is feedback. So I'm going to speak slowly because my slide is just around 20 slides. So it doesn't really need 45 minutes. So we can have a early lunch break, and you can take longer and can enjoy the food from the hotel, food and beverage. Okay. Despite the feedback, so my topics is about social computing for information technology transformation. I'm sorry, I have to put a lot of icons from association. In the morning, we already meet Pak Endra. He's also from a chapter from Indonesian section. And in ITS, Institute Teknologi 10 November, we have also IAS, Industrial Electronic Society, even though it's not mainly in electrical engineering, but we can also make a little bit larger by industry. Okay. I'm sorry, could you please next for the presentation? Yes. Okay. When I asked Mr. Agus, is there any tagline or topic for this conference? And he said that information technology transformation amidst digital disruptive. After this slide, there is some image. I think this is made by volunteer.
Delay di sini.
Okay. Less delay, but still delay. Okay. There is a survey from McKinsey that there are around 12 disruptive technologies. I mean the technology that make changes. And from the first keynotes, Dr. D. Red already said about autonomous, and because I believe in Thailand is famous from agriculture, so the autonomous is what's it called in English, but in Indonesia we call it bajak. Yeah. I'm not sure what's in English. And also Masato Sensei has already talked about information networking, especially underlining since the pandemic, there are increasing traffic in internet traffic increasing. Yeah. So in my case, it's not the social media. I mean, it's not the information traffic over network, but it's also using some kind of information in social network. So that's definition when I Google in internet what is the digital disruptive. Even though it's not very common to use social computing, but we usually use social media analysis, or perhaps sentiment analysis, or perhaps in a Twitter analysis and so on. But there is terms social computing that's a part of a branch of computer science, but focusing on social communities. Okay, next. Okay, this is the image that I mentioned before. It's from McKinsey company, so it's a very old management consulting company since 1900. And in his recent report, the company said that there is 12 disruptive technology, and there is someone volunteer from Singapore makes this nice mind map. So I believe the first presenters, Dr. Diklet, talk about autonomous, and I make some advertising from ITS. We also have autonomous. It's called iCar. Symbolic for ITS car, and also we have iBoat, and that's the product of in Indonesian we call it PUI, Pusat Unggulan Iptex, or Center of Excellence. MIA is related to mechatronic, and the leader here is Dr. Rudy. He is also right now become the leader of a Center of Excellence in AI for Healthcare and Society, because ITS, we right now, we want to broaden our program study is not only to technology, but also related to healthcare, like medical technology. And I believe in the beginning of this conference, I talked with some old friends that UPN will also open a new study program related to the medical engineering. Okay, so and then the second presenter, Masato Sensei, it's also talk about mobile internet, but focusing on the information networking. But in this talk, it's also related to the mobile internet, but in the data. Okay, next, the data, I mean, is the social data. Okay. When the term of social computing, actually when I Google, there is a very old article by ACM. I believe we already know ACM, and it's before 2000, there is already term about social computing. But at the time, I think the definition is a little bit limited to the software, but we can focus on the number one and number two. At that time, the author has already mentioned that software, or in this case, perhaps social platform like Facebook and so on, will help people to communicate. Whether at that time we still have a news group, but right now perhaps news group is already people using it less and less. So 20 years later, please next next slide, please. Next slide, please. I'm sorry. Okay, so 20 years later, okay, I got the nice article from IEEE transaction. It's still on last June, and it's also talk about a survey on hybrid human AI for social computings. Okay, it seems that although my presentation created by PowerPoint, but it really look it's not nice anymore, perhaps because of those formats. So anyway, so for in those article, it is said that social computing, there is a term for swarm intelligence. We already know that swarm intelligence like algorithm inspired by natures, like how honeybees migrate with ABC, artificial bee colony, or ant colony, or perhaps particle swarms, like how birds flock. So the implementation is, let's say just one people using Google Map, okay, and then using activate his or her GPS, and it send a signal to the telephone company say I'm here, and a lot of people using those kind of application, and we call it as a swarm intelligence, and then those information are used by Google. And then the Google can create a Google map like this one. There is a path, shortest path, and there is color. I believe 5 years or 7 years before, we do not see the color red, yellow to sign there is a traffic over there and we have to find another routes. But right now, Google has already, I think it's about 2 or 3 years, yeah, the recent 2 or 3 years have this kind of features. And then this is still new. You can see that it's for Amtara News. It's still June. Google will give a new feature to estimate the cost, because in Jakarta, there is no regular street. There are only highway, highway and highway and highway. Okay, so I think that's features generated by swarm system. We call it swarm because there are a lot of people or participate in those system. Okay, next please. That's social computing. And then social computing for social media, Spotify. I think perhaps 10 years ago, I still have, this is an online and international conference about pirates, okay. I like to download MP3 and then, okay, this is a pirate from, I don't know, someone already make it online. But for the last 2-3 years, Spotify has already emerged. And yes, it's not, I don't know, is it expensive or not? But right now, 2 years before, I said, the internet is very slow. I cannot enjoy music. But now every day when I have to take my child go to school, I play Spotify in my car every day. And then while I'm working, I play Spotify to distract, I don't know, whatever sound outside. And Spotify also launched some kind campaign within social media. It's called Rap. And that's a very successful campaign because people tend to share, I like this music, I want to share this music. And those information are being used by Spotify to make some kind of marketing, and then Spotify can give to the artist perhaps or to the company, music company, for market segmentation. Or in Indonesia, people perhaps likes folk song, or perhaps in I don't know, in Jakarta, people like K-pop perhaps, because youngster right now are really into the K-drama and so on. Okay, so that's also social computing. Okay, next. Okay, aside of social computing, I think social media, social network, we can say it, same, almost the same, but in social network, there is a representation called graph, and each node or each user, each Facebook user, each Twitter user makes some relation to others, whether just giving like, hands down, or reply, retweet. Those kind of information can be represented as a network, and then as a recommendation system, we call it a collaborative recommendation. If you perhaps familiar with Tokopedia, e-commerce, or Amazon, after you search some books or some products, in the bottom you will see perhaps you are interested in this kind of product. Okay, we call it collaborative recommendation. Why? Because the world is very large. Some other peoples also have the same patterns with you, and then the Google, the Amazon, or the Tokopedia can give you recommendation to those products. And that's why right now Tokopedia, Bukalapak, and those kind of companies are very interested with informatics alumni to become as their data scientists, their data engineers, to make this kind of recommendation system. Okay, next. Okay, and then social computing for personality computing. So the personality here means usually they try to relate with some theory for big five theories. I think in the next slide, there is a big five personality trait. And then we can relate those information, whether someone have capacity become a leader or have capacity to become sharing knowledge. Those kind of information, we call it also as a social computing. Okay, next. Okay, and then also the effective computing. I guess the effective here, and by definition, is sense the emotional state of user and respond with a specific services. When I Google it with just effective computing and then disruptive technology, there are a lot of startup company like in here in German to help older people to decrease the Alzheimer potential. So they create some kind of robot, and then the robot have a lot of sensors, so they can become the company for the older people. Okay. But I guess for if we use the term sense the emotional state, I think there are a lot of in the recent technology, we like to use smartwatch. Okay, and the smartwatch we can detect our heart rate. How many steps are you? Okay, this is a little bit out of topic, but I read in some articles that Indonesian people are categorized the laziest people in the world because in average, the world average for how many steps you can do is about 4,000 or 5,000, and Indonesia are less than that. And that's why I don't know whether is Masato Sensei still already here, But in the beginning of October, I have a chance to visit Japan, and at that time I have to walk. And then I install some application in my mobile phone, and then try to calculate how many step in a day, and it's 10,000 steps in a day, because I do not use car. I just walk, and then use subway, and then try to move around between subway or using bus. It gets 10,000, as easy as like that. So, okay, so perhaps everyone in here can at least try 3,000 or 4,000 steps, at least, yes. But it's also advice for me, because I think during pandemic, I'm gaining weight every year around 1 kilo. So it's more than 3 or 5 kilos than before. Okay, next. So, okay, in short, this is the 5 point here is some research that right now have been done by our laboratories. It's also collaboration with other laboratories across departments. So it's still about social computing, but in a lot of different areas, such as in health related situation, it's understanding online consultation like HaloDoc. But it's not just about sentiment analysis. It's not about topic classification, but when we visit a doctor directly, there's always some steps, like introduce yourself, what is your symptoms, what is your problems, and those kind of steps are defined by, this is a journal in medical education. It's called a medical interview function. So there is a fostering relationships, asking who are you, what are you doing in every day, and then also gathering information, providing information, and so on. So that's why we try to, after downloading around 200,000 data from HaloDocs, and then try to annotate and do something with those data using this medical interview function. I think some slide after this, there is some steps related to the research number 1. And also another research about social computing, because next years we have election from I think it's I don't know who's the candidate from the next president. So the I think that's point for number 5. Understanding participation rates in electives. But we also want try to whether in this certain area will be increased or not based on the crowdsourcing, the opinion from the local people. And also the dangerous speech, I think it's common for hate speech, hate or no, but there is a theory. So from recent research, I think it's really interesting to join in a social computing area. It's not just in computer science, but please try to mix it with like a psychological, like personality trait, or based on the economical science. So in a dangerous speech, I think that's from the psychological perspective. So any posting, whether this is some kind of terrible or like hate speech, but it's not dangerous, because we label it is dangerous or not if there are others who respond to the statements. That's why after finding the context, in here the context is like dehumanizations Dehumanization, it means like using some kind of you are pig or something like that. So it's called it's defined as dehumanization. Or accusation in a mirror, it's kind of racialist, like in Indonesia we tend to have racialists in Chinese racialists and so on. That's accusation and mirror and so on. So we try to identify social data analytic. It's not only for hate speech, but try to measure the level of hate speech. It's called dangerous speech. And also because of pandemic, people will increase use Twitter or Facebook, and that's why whether there is a tendency to some kind of behavior. It's not always a sharing behavior, but I don't know, psychological, psychopathic behavior, or and then crazy behavior, any kind of behavior. But in this case, we are still limited to the sharing behavior. And also, this is not a social media data, but we try to represent the data as a social network. It's called expert from behavioral based publication activities. This is actually the data from we are as lecturers. We submit something, we publish article, we make some co-authorship collaboration with others. Those kind of information can also be represented as a networks. When we work or doing something, we make some kind of social relations. That's why it's also social networks. So that's the variation for social computing that right now are engaging in our laboratory. Okay, next, please. So that's the first steps. I'm sorry, my presentation is very simple. It's just some step without any not heavy on a theory. So for understanding online consultation, I think that's a basic situation using natural language processing. You have some data, and then because we try to understand from a lot of unstructured text which part is a fostering relationship, which part is providing information, and then we call it as a text segmentation, or we try to find is there a special entity related to the health terms, so name entity recognition. And then based on those information, we try to create some kind of category, or we call it taxonomies, and then so on, and then try to make it social social computing by using not only one information, but also a lot of information, a lot of user who asks in the online consultation, whether they reply or whether they also ask the same question. So that's we call a collective diagnosis. Hopefully, those results can be become a benefit to as I don't know, like how do you say in English about puskesmas ya? Have facilities. Perhaps there is some kind of local policy from government to make some preventive measures. Okay, next. I think it's just 2 or 3 slides and then we can finish. Next, please. Okay, and then for those dangerous speech, I think it's almost the same. Try to find the context, also the aspect, because from dehumanization, if we analyze the data, there is some kind of pattern, there is some kind of similar terms that always used in those context. So that's why we try to, perhaps we can call it as aspect based. For NLP, usually there is term APSA, aspect based sentiment analysis, but we do not use sentiment analysis, but we try to find it as aspect based. And then because this is tweet, also we can have some behavior. So the response behavior to those tweets, whether it's reply, retweet, comment, and so on. Okay, and of course for dangerous speech, there is need some module to quantify the level of dangerousness. Next. Okay, so this is the sharing behavior like I mentioned before. Please try to connect with other theory. In here, there are theory of planned behavior or like, I think this is the from a friend of mine. He is a lecturer from Udinus. She tries to find the potential of student entrepreneur. So using theory of planned behavior, because she believes that entrepreneur can be nurtured. So how do we know which student have a higher possibility to become entrepreneur? And that's why she tried to connect with the academic activities, academic achievements, or perhaps their backgrounds, and then try to map it with whether is there any existing theory that supports those entrepreneurial behavior. And there is a theory, it's called theory of planned behavior, or the updated version or more specific version is theory of reason action, and so on. So for social computing, please don't focus only on computer science algorithm, because it's social. You need to take a different perspective from social perspective. Okay, like in here for sharing behavior, let's say we try to identify some index for sharing, index for trusting some sources. We can call it as a trust model, and then index for others. So just try to make define something. I think that can also become your inspiration if someone haven't got their PhD. Okay, so and then based on those index, the easiest, not the easiest one, the more clear definition is using regression analysis, because we want to correlate some factors about dependent information about the index to something behavior. So you can define whatever behavior that you want to explore. Usually in social media, we can have a content. Content is the text itself. Context is any kind of information related to content, whether it is we can also call as a metadata, like retweet, or like how many or the frequency of user report to those kind of posting. If the posting is very interesting to others, and there are a lot of news report the same issue, I think there are a lot of user will reply to those posting. It can be said that is context information. Or also we can structures or make the relation between those users, whether it is the first posting or then the ones who replies, and make some kind of relation. That's become structure, that's social network, and try to combine those three informations. I think that's the basic approach for any kind data if we want to focus on social computing. Okay, next. And then this is a little bit different, and this is from my dissertation. So it's not social data, but we can try to represent real data, any data. If we can find some kind of relation representation, then you can make a network. And then from those network, perhaps you can find a new features to extract. In my case, I want to find which one who is expert on something. The expert is not just from high citation that he or she got, but how often he likes, how often he publish something to those certain topics. Or perhaps he or she wants to disperse his or his topics. So the exploration, I call it as a topic exploration and also topic consistency. Someone who expert can be expert in a horizontal or can be as a vertical. So okay, scan next. Yes, I think that's the last one. So in a close note that social computing intelligence related to how we quantify information based on human or social behavior. And hopefully for those computation, we can get some insight, and those insight perhaps we can use as a market segmentation, brand awareness, like Facebook and Google is here. All of those information in the search engines can be used for others application. I guess that's all for my sharing. Hopefully it's not too short. I believe it's 15 or 20 minutes or so. Thank you. The time is yours.
Thank you. Thank you, Budiana. Please give her an applause, big applause for her. Okay. Thank you so much for delivering such a wonderful presentation in the area of software, social computing. We have seen so many open area. Yeah, I think open area on how we can do research in the area of computing in many different areas. I think we can also connect this her idea, her research, with the one that has been done by Professor Masaru. I think because when we talk about disasters, then we rely a lot on the data that we can collect from the affected area. And if we apply the social computing on that area also, we can also collect information from them into one pool, and then we can analyze, and then together with the information collected by vehicles that Professor Masaru has been has said that, I think we can come up with a better idea on how to respond whenever disaster happen in our area. So one more time, let's give big applause for all our speakers, whether it's online and here. Okay, so I think I'll turn to the audience here in this room. Not many actually, but I believe some of you have something to ask to our speakers. So please do so. Please stand up and then mention your names, your name, and where you are from, which organization, and then to whom your question directed to. Please, can I have any participant from left side or right side, perhaps? Yeah, on my right side. Okay, please wait for the microphone, please.
Okay, thank you very much. My name is Andreas Nugroho. I'm from Department of Informatics from UPN Veteran Jawa Timur, Faculty of Computer Science. I have a question first for Professor Masaru. For the data collection with vehicles, the assumption, we are not clear about the assumption, how much or the maximum radius of the operational vehicle, theoretically, in that presentation. And the second for Professor Diana, may I ask how strong the correlation between policy of social media and the relation with the dangerous or hate speech that you present? For example, like this, Facebook usually only show our interests, but maybe they not show something that beyond our interest. And then, but in Twitter, our interest or not our interest, or usually promote in homepage. Okay, something like that. And in Instagram, sometimes there is sponsor content that maybe we are not interested, but we have no interest, but still show because it is on our city or our province, something like that. Thank you very much.
Thank you, Mr. Andreas. I think before everyone forgot what is the question, I think I will ask Prof. Masaro did you hear what the question is?
Okay, so your question is about the number of vehicles in collecting information, right?
Yes.
So, if we search or design entire patrolling routes with many vehicles, the complexity is very increased. But in reality, we can divide the region. For example, north region, south region, east region, west region, and for each region, assign 2 or 3 cards. So we can increase the number of cards by using the area segmentation. It can be answered.
Does that answer your question, Mrs. Andreas? Or maybe you can elaborate more? Yeah.
Sorry.
So basically, it's for specific location, different radius or different formula implemented. Is that it? It based on specific location or different location, different case, different methods, different radius, something like that.
So my answer enough for you? What I want to say is we can divide the areas. So for each area, the number of car we need is not large. So small vehicle can use in each area. So the total number of vehicles can be large to make the information collection fast.
So it really depends on the location, correct, Professor Tasaru?
Yes.
Yes. That's why I think in one of your slides, I think you have talked about if it is possible to create some kind of segmentation or something like that. I believe in one of your slides is saying like that. So if every province or every department, region, kabupaten apa ya, every province, they have their own map of any location, especially those area with higher risk of
Yes.
disaster, then it will be good for the application of your algorithm, I think. Okay, so let's move to the next question for Ibu Diana.
Yes,
Please.
thank you, Mr. Andreas. So we limit our context to dangerous speech on Twitter. So in a Twitter platform, everyone can talk anything. So garbage in, garbage out. Okay, that's why there are a lot of pre-processing works, the step that should be done before, and it will be more easier, at least if for a dangerous speech, if we want to know whether it's dangerous in which domain, in which issue, in which topic. So I guess that's become starting point. If you perhaps want to limit the dangerous level on certain issue or certain account, that will be nice. And also, if we want to select some accounts, we also have to at least make a rough analysis whether what kind of background for this account, and then starting from them, at least we can have some seed information to crowdsourcing or scrap the data from Twitter, and then the next standard process for NLP we can on those texts. I hope that can answer your question.
Okay. Thank you very much.
Okay, thank you, Dr. Diana and Prof. Masaru. So, is there any question from the middle? Oh, back there. Okay, Pak Basuki.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
My name is Basuki Rahmat from UPN Veteran X Java. To Dr. K, our Associate Professor Dikrit Manitam. Okay, it's very interesting about robot, especially in Indonesia. Is I think almost the same with Bangkok. I think is it, especially robot for agriculture that you explained just now. Maybe have you ever combined, for example, if robot in the land, we know the drone in the air. Have you ever combined drone and robot system to together to, for example, how to get the synchronization and organization the data in order we help the farmer especially. For example, if drone we can use as to detect disease or some pests in the plant, and then the robot will come to spray, for example, like this. Okay, have you ever maybe? Thank you very much.
Hello, thank you for question. For this question, really nice because this if we use for this drone as for research, that means drone you can design for this control as position and speed together. Then example you can turn via PID controller. After that you can spray everything in your pants. Then example for your design for this PID controller. This example for your drone. Then drone stay in us up for this the land allow us 5 minutes. After that you can control via PID controller. They can slow down. Okay, that means you can check for this the graph. After that you can up and down every time for your controllers. PID controller via drones. Okay, so for drone you can use lots of controller. Example for Pythons, for library price and latte panda. So lots of CPU. That's been so small. After that this CPU lots of connector for this I/O for internet cable or for USB cable together. After that you connect this cameras and touch screen together. After that, you can take off mouse and keyboard together. So now you can control via PID controller for drone. After that, you can control everything for your need to spray your pan and light for food, everything for this your drone. Okay, thank you.
Okay, thank you so much, Professor Dekrit. Okay, is there any more question from the audience here inside this room? Okay, one on the left, Mas Aris, please.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. So my name is Afif. I'm from Politeknik Negeri Malang. I want to ask Bu Diana about the social computing, Bu. As we know, in the term of artificial intelligence or something like this, the technology always step forward behind the ethical policy or something like that, the government policy and so on. My question is, the first one is how we prevent ourselves in terms of doing social computing research to not crossing the border in terms of social or ethical policy. That's the first one. The second one is about the data collection in social computing. In the NLP, it's almost the data that we use is text, right? And then in your experience, is it possible to use any other data such as emojis to represent the research that we are going to do, but not only using the text, but also we combine it with the emoji, because sometimes people in the internet only post emojis and it's very tendencies to racism or hate speech behavior. Thank you.
Thank you, Mr. Rafi, for this very nice question, especially about ethics. Because, yes, that's a very rather debatable issue, yeah. But Twitter, essentially, it's we can say it's a public data. Because people say, oh, look at me, or see my posting. So I think we can categorize it. This is a public data, but if we want to analyze something and then we make some conclusion on perhaps certain accounts, so I think in a ethical perspective, we have to honor the a user who owns the account, and then yeah, it's not really nice if we very harsh statements to those analyses. But in for the data itself, I think that's public. And then for your next question, there are already some research how to use emojis. So it's falls on the pre-processing steps. So, but it's really difficult because actually the emoji in different countries are different. In Indonesia, we tend to use smiley faces. But when I visited Japan, I think around 2 or 3 years before, the Japanese people tend to use not smile faces, but a combination of titik dua, how do we say titik dua? Column, and then bracket, and then how do you say chopping? And then those kind of characters and make looks like faces or expression, or like to crying, they use at to show that it's tears. So I think for emoji you have to define different pre-process and different dictionaries to explain the emoji, and then use it in the pre-process, and then after that you can perhaps label it as a sentiment or emotion, and then so on. It becomes a new kind steps for feature extraction, because that's also different kind of features. I hope that's answer your question, Mr. Raf.
Okay, thank you, Bu Diana and Mr. Afif. Is there any more question? Okay, perhaps one last question for Prof. Daitik. It's just out of curiosity, I think the agricultural application of the mechatronics, I think, is very interesting. But did you take into account the different contour or different terrain on your, what do you call the engine to plow to plow the did you take into account that that terrain or contour already, or is it on the regular terrain, something like that, Professor? Professor Tekrit, do you hear my voice?
Hello. Okay. Sorry, Professor,
Yes.
I didn't hear because it's very problem for noise. So for tractor to control with we have fat only, not anchor. So now this fat that means like unmanned together. Then we control via at first we control via remote control. After that GPS control. So now I classify for this control devices two paper. As first paper control via this remote, and second one for light intelligence, GPS and compass together. So now this control via fast. Okay. Yeah. Thank you, Professor.
Okay. Okay. Is there any more question? I'm seeing here in the online YouTube, and there's no question for. So I think we will conclude this meeting, this session, because there is no more question from the audience. So today we have heard a lot from our speakers. We have so many things to learn from them. Professor Dekrit, especially, he delivered speech in the application of mechatronics in various fields to support patients in hospital. And then Prof. Masaru, he has delivered the how to calculate, how to collect data, how to collect data from the disaster area whenever the information infrastructures are knocked down by the disasters. And then the last one, Prof. Diana, she delivered speech on social computing and many different areas that we can explore all together to make our life better in the future. So I think that's the end of our session. I'm Afandi as your moderator. I would like to ask for apologize for any shortcomings that maybe exist in this session when I try to moderate this session. Okay, so once again, thank you very much to all of the speakers of this seminar. of the keynote speakers session, Prof. Masaru, Prof. Dietrich, Prof. Diana. Let's give them another big applause for them. Okay. Hopefully we can meet again in the coming ITIS 2023. I don't know whether it's going to be in Surabaya or other city. It depends on who the dean of the faculty. So let me close this session by saying Alhamdulillahirabbil alamin. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. You have all a good day. Thank you. So I give the session to the MC.
Okay, thank you, Mr. Moderator. Thank you so much, Associate Professor Dr. Dekrit Manetham, Professor Masato Suru, and Dr. Diana Purwitasari for giving such informative and interesting presentation. Thank you also for Mr. Irwan Avandi for being the moderator of the keynote session, as well as leader of the fruitful discussion. And again, thank you for the participants for the active participation. Please give another huge round of applause for the speakers, the moderators, and for you all. Okay, ladies and gentlemen, you are welcome to take a break until 1 p.m. Then we will continue to parallel session at 1 p.m. both offline here and in the Zoom link. We need to inform you that the presenters of the parallel session are welcome to immediately assign in the breakout rooms provided by the committee or in the hotel room as written in the parallel session information has been shared in the WhatsApp group. We are also pleased to invite participants of this seminar to join the breakout rooms according to the theme you are interested in. Thank you so much. Enjoy your break time.